So welcome everybody. Welcome to our first actual idea talk of the fall 2019 season. As most of you know, we try to intersperse on these Wednesday evenings TWED talks down in Winslow, which are topics of interest to the Television World Constellation, semantic web, knowledge graphs, these sorts of things. Idea talks, which are grad students and visitors connected to work that IDEA is doing more generally, and they're happening here. And also our Pirates meetings, which are approximately once a month. Our Pirates, the RPI, our users group meeting. Tonight, we have a visitor who's come all the way from France, all the way from Paris, to experience our wonderful weather and to give us a talk on inside. I've been advertising it as an insider's view to standing up machine learning challenges. Adrien has been associated with the Coda Lab, the Chalearn Lab, run by Isabelle Guillaume, who manages the Coda Lab, which was originally created by Microsoft, and has been the management of that was handed over to Isabelle's organization. Adrien's been working with us for some time, helping us understand how to set up challenges. And we also have a guest in the back, Tyler Thomas, who is a developer who has actually been supporting the Coda Lab platform. The long-term view, so Adrien and Tyler are here this week as part of the United Health Foundation Health Data Insight Project, which has been funding all sorts of things over the past couple of years. And we are, the ultimate objective is that we will actually be standing up machine learning challenges on an internal platform for various courses. So with that, I'll turn it over to Adrien. Thank you.
Thank you, John, for the introduction. And thank you all for coming. So we are going to talk about machine learning challenges. And if you don't know anything about it, don't worry, because we are going to first to see what it is. So the presentation is going to be divided into three parts. So firstly, what is a machine learning challenge? Then we will see why we are organizing and participating in them, what are the advantages of it, and the reason and the usefulness of it. And lastly, we'll see how to organize machine learning competitions, to make a good machine learning competition, but also more concretely, how you really upload it and make the website to work. So firstly, what is a machine learning challenge? So vaguely, this is a way of solving big AI problems. So it can be scientific ones, industrial, but also more and more societal and ethical problems by using a competitive framework. So this is really a competition between humans, but also a kind of competition between methods of machine learning. So every participant try different methods and submit their results, which are then automatically computed to get a score. And so the goal for a participant is to get the highest possible score and to be well ranked in the leaderboard. And eventually, when the competition ends, if you are in the third places, you win the competition, and you can win a cash prize from $100 to $1 million. So it really depends on the challenge. So yeah. So to give an example, if you never heard about challenges, let's dive into a simple example. So firstly, you need a task. So in this case, face detection, which means automatically compute if there is a face or not in a picture. This is quite an interesting task. Now we have our task, we need data. So our data set will be pictures, maybe thousands of pictures of face or not face, and for each picture, the solution. So this is a supervised learning framework in this case, but there are a lot of other possibilities. And really importantly, you have to divide your data in two sets, at least two sets. There can be more, but at least two, because participants are going to train their models in the train set, and we are going to test the scores on the test set. So the solution for the test set is only for organizer and is hidden to participants. So basically, they have to predict the solution for the test set, and then we are going to compare their proposed solution to the ground truth with a metric to give them a score and a rank in the leaderboard. So you then need a metric. So in this case, we can choose accuracy, which is just the rate of good answers. And basically, that's it. And so the method used to tackle the problem is up to the participants, meaning that they can do whatever they want to do their best to win the competition. So if you never heard about machine learning challenge, I think if you remember this, you had the whole idea. So competition are in a platform, so there are many platforms for competition. Ours is CodaLab. So the main advantages of CodaLab over other platforms is that this is an open source project, and it is free to everyone to organize their own competition or participate in as many as competitions they want. So this is really what makes this platform unique. So as John said, it was created firstly by Microsoft and as well as Stanford 7 years ago, and as well as some people from Chalern like Isabelle Guillon, and Eric is the main developer of the platform with Tyler, which is in this room. So quickly, some history of the platform. So in 2013, there was the first competition uploaded. So the brain tumor segmentation challenge was the first one, I guess. And then the next year, computer vision challenge got some quite decent participation with more than 300 participants. Then new features got added, like code submission. So we are going to talk more about that later, but basically it's instead of submitting your result, you can submit directly your model, which will be internally trained and tested in the server. So this has many applications. For example, if you have private data you don't want to share with participants, or if you want to be fair, like having the same computational resources for every participant. And so 2 years from now, there were less than 500 challenges and a lot of users in the platform, so it's really growing fast. So let's take some examples of past challenges. So you see some example and how they're useful. I think you may have already heard of ImageNet dataset. It's a really famous computer vision dataset with more than 14 million of images labeled. So each year there is a challenge with this dataset, which is growing, and this is what led to the big explosion of deep learning methods and the use of big neural networks these days. Another example is the Learning Torrent challenge at NIPS conference. So I took this example to show you that there are not only classification and regression problems. For example, this one is a reinforcement learning competition. If you're not aware of what reinforcement learning is, a different framework in machine learning where instead of having data, you have an agent that takes actions and gets some feedback from his environment. So in this case, the agent is supposed to learn how to run in a 3D environment, and the reward or objective function is how far we can get in less time as possible.
Is there like a model in the track that you can evaluate, like a physical model of the world or something?
Yeah, that's it. It's a 3D modeling with some basic physics law like gravity, and basically the agent can control articulation and muscle to try to move. So it begins maybe randomly, and with learning it tries to find the good move to go through this fake 3D world. So that is another example. The AutoML challenge series are challenges where the goal and the task is, as you can guess, to automate the machine learning process, so the model selection and the tuning of the models. So in this case, there are many data sets, and participants upload their models, and the data sets are hidden, and are various tasks such as, for example, images, videos. It can be from different domains like medical data or satellite images. And the goal is really to try to find models that is able to handle really different data sets and do the best score as possible in every task. So there has been many AutoML challenge, and even this year we are still creating new. So this year we're launching the AutoML Auto Computer Vision Challenge and Automatic Natural Language Processing Challenge. And in December at NIPS conference, we are going to launch Auto Deep Learning Challenge with really a lot of various tasks. So it will be a very exciting challenge. The last example I wanted to take is the CHEMS challenge, which Christine used during this class. I just wanted to take this example to show that competitions are not only for big experts and big research team for high cash prize. It can also be used in the classroom for students, and it is really motivating to have an environment where you get a real-time feedback for your submissions. And as you can see, there were some students who did a lot of entries because they're trying to tune their model to do better score and beat their classmates. So it's really a good way to learn machine learning too, and to try to go further and learn new methods that hasn't been learned in class. So that was for the example of challenges, and I think you begin to see how useful it can be. So let's see why we are using them and why we want to organize and participate in challenges. By the way, if there are questions, feel free to ask during the presentation or add remarks. So for organizers, challenges are really a good thing because basically the participants are doing the hard job. So you can get really good solutions for your problem thanks to the crowd wisdom, which basically says that if a lot of people are trying to do something, you eventually get a good solution for your problem. So this is really why, as an organizer, you would want to organize one. And it's kind of related with the second point, which is it's kind of cheap because you put efforts to create your challenge, and maybe a huge cash prize, which can seem pricey, but you can get hundreds of team of experts trying hard to solve your problem. So this is priceless in this case. So you can really have good solutions instead of just putting like one team trying to solve your problem. You're really having a good solution. And for participants, there are a lot of different rewards. Of course, the cash prize, but it's really not the only reason to participate. So of course, you can have knowledge as for the students or even researchers who can try out their method and know what works, what does not work. And so this is an access to a kind of playground, because the organizer already do the boring part of gathering the data and making the protocol and everything. So you can just go and try your things and check if your method works in different problems. So you have really a lot to award from participation, as well as also sometimes jobs and paper opportunities for example, if you do well during the competition. And just to show you that cash prize are sometimes not the biggest reward. So this is examples of challenges on the Kaggle platform. So this is the other big famous challenge platform. So you can see that there are a lot of million prize challenge, but this one, the Higgs boson machine learning challenge, had a small reward in comparison to others. So 13,000, if you can see it. And it has a really good participation with more than 1,000 teams. And this was because at this time the Higgs boson problem was really hot in physics research, and this challenge gave access to really important data from the Atlas experiment. Researchers were really more interested by the task itself than the cash prize. So now let's see how to organize a machine learning competition. And so as I told you, it's not really hard to do, because the participants do the hard work, and as an organizer you just have to create the task and give them. So it's kind of easy, but not stronger than its weakest link, because you have a lot of different things to do, like choose the data, choose the scoring metric, create documentation, rules, and in any step, if you fail, you can really have a bad challenge, let's say. So what makes a good challenge? Firstly, you need an interesting task. So as in any scientific or industrial work, I guess the first thing is to have a good task. Having enough and good quality data. So we are going to talk more about data just after. A clear objective and a good metric. So we are also going to explain more this point just right after. And of course, some other ingredients like the prizes and the feedback. And also a good starting kit is really important. So what is a starting kit, you may ask? So the starting kit is a pack you give to newcomers to your competition, which help them to dive directly into your problem without having to bother with boring stuff like you give them instructions, but also pieces of code or notebook which already read the data, train a basic model on the data, like a logistic regression, let's say, and then repack a submission so they can really quickly go into the challenge and just replace the method by another to try quickly if they're interested in putting more effort in your challenge. So this is really an important part if you want to have a lot of participation and all. And I also added fun because, yeah, I think it's something that really get people to do.
Depending on how you do the other things, the fun kind of comes along.
Yeah, indeed. So, talking about data, so Peter Norvig from Google said, we don't have better algorithm, we just have more data. And I added a kind of rule on thumbs because this isn't totally true. So what I said is more data beats better algorithm, but better data beats more data. But basically data are really everything in data science. So you really need to work on your data set. So you have a lot of possible issues you need to be aware of with your data. So firstly, having enough data, and more your dimensionality is big, more you need a big number of examples. Of course, it depends on many things, but basically we can say that. having a good train, test, and validation split design, I think the most important part with that is, for example, to have enough data in your test set, because you really want to have good error bars when you're evaluating the different submissions, because it doesn't make sense if you don't score well the submissions. There are a lot of also possibilities of data leakage, so you really need to be aware of that when preparing your data set. For example, a bad train test split could be a medical data set. If you have, for example, data from 10 patients that are maybe 100 of examples for each patient, you need to split and keep every patient in the same set to avoid data leakage. There are a lot of tiny possible errors, also confounding factors, and I'm going to show you a slide about this. And the last thing is the bias and variance trade-off. So the variance in data is generally when you doesn't have enough data. Nowadays, it's not our biggest issue because we have a lot of really big data sets, but the bias issue in data is emerging more and more, and there is also a lot of possible bias. So about confounding factors, I took this example of that competition where you were supposed to classify objects, so planes and cars, things like that, and you may guess what the problem of design was on this one. So the task was finally just to recognize, and so this is a big data leakage. So the models weren't learning to recognize the shape of the planes, but just the color of the sky or of the ground. So this is, yeah.
Is this for real?
This is for real.
I mean, the problem is you're not going to see a plane on the ground.
Yeah.
The problem is which is a plane, which is a car.
Yeah,
the problem is which is the shape.
So you success in having a good score, but that's not what the designer of the challenge wanted in the first place, obviously. So this is the NORD dataset, which is an example of good design on this problem, because they remove the colors, and the models are really looking at the shape of the objects in various angles to avoid also, for example, if each plane are in the same angles, it's also the data leakage. So you really need to think about a lot of things when designing your data set to really tackle the task you wanted to tackle in the first place. About bias, so there are really different possible bias in your data, like sample bias, and it is really an emerging problem because you can really have like this word say discrimination, prejudice, and everything in your data. So I don't have a good example of this, but let's imagine maybe if you try to classify between women and men pictures, and but no, you have every time you have a woman, she's in the kitchen, let's say, and so you will have a real bias, and you misclassify a man because he's in a kitchen. Okay, that example isn't really good, but to get you the idea of what can be a bias in the data, because we mostly talk about bias in machine learning models, but the data itself can really be biased, and we can't really rely too much on them. The last point about how to design a good challenge is the metric. So the metric is really the measure of your success in the competition for every participant. So it's really important as an objective. For example, if you have a binary classification task with imbalanced classes, so meaning you have one class that is overrepresented, and you choose accuracy as a metric, I think you can see the issue coming. So just a classifier that will only send the overrepresented class will have a good score. So you really need to choose a metric that fits well your problem. And there is a sort of rule of thumb about that. So in this diagram, which comes from the AutoML competition, you have in blue the score of the, so it's like an accuracy score, or maybe an AUC score of the baseline method, so a really simple method. And in orange, here, the score of the best submission. And basically, you want your problem to have the biggest orange part as possible. So this is what we call the high modeling difficulty. And this is what makes your problem interesting and have a wide variety of possible scores. So that is also something you really need to look at.
What's max best? Is that like email context?
It's just to say that I mean, the interesting difficulty is how much the score is high on this task. So, for example, this one, the best possible score was under 0.4, so we can say that the intrinsic difficulty is really, it's a high difficulty. So this is just the comparison to the best possible score, which is 1 in this case. So I hope this is clear enough. So that's for the part about how to make a good challenge. So just to finish, we'll see more concretely how to create a challenge on Codalab. So we have this pack that we call a bundle. So you have everything that defines your competition in it. So the description of it, the different web page in HTML format, a program for the scoring, as well as, of course, the data and the starting kit. So the thing you will give your participants to help them. And so you pack all of this in a zip file, upload it on Codalab, and then, tada, you get your website with your challenge, and you just have to go to participate and try to submit results or code submissions and get it to work. So, and after that, as an organizer, you have an editor that you can use directly to rechange the data set and the title, let's say, the start date of the competition. So it's really easy to use, even without a big background in computer science. So that's make it easy to use for as many people as possible. Just some more detail to finish. So here's the link of the wiki of Codalab. I think we already talked about code submission. This is really a useful feature. And also we can add compute workers for computationally demanding competitions. For example, in the automatic machine learning competition, we have a lot of GPUs. So every code submission is run on one GPU, so you can get your results quickly, even if it's trained on 5 different data sets and then tested on it. And in the future, we are going to add the Codalab benchmark features, which is basically competitions but without end date. So you just keep the playground open, and with the advancement of the machine learning techniques, you see how much you can go on the program. So that's it. Thank you. Do you have any questions?
You know, we have plenty of time if you wanted to do like a live demo of creating, you know, just, you know, you'd upload one of the examples and just show.
Well, if you're interested in, we can do that.
Oh yeah, sorry, I did have one question for you.
Yeah.
If I set up and do a project on Codalab, who owns the code that the computer is going to run?
Like I'm gonna do I own a GPU machine. I'm gonna set up the competition.
people are going to submit models. Those models are going to run on my computer. Can I see the code? Can I steal that code? Is that stealing?
Generally, when in competition you have code submission, there is clear rules about it. For example, in the automatic machine learning competition, we said that if you want to earn the prize, you have to make your code public, and make it open source. So you choose in the rules what they are going to do with the code. But usually, if you send your code into a server, you're aware that it is readable by the person.
Yeah, I guess my question is that something CodeLab decides, or the person running the competition decides?
It's more something the person running the competition decides usually.
There's also other types of competitions, like the competition usually runs a class, you don't submit code, you just submit permission, right? So the permission
Yeah. This is the most common use, is you result your proposed solution for the testing set. But yeah, it depends on the competition.
So the point basically on the same question, the point that you made about the advantage of a code submission type contest, of being able to apply that code to data which is not released, is really interesting.
Yeah. Yeah, that has some good applications. Like you don't want people to be able to tune by hand their models, or as I was saying, with private data. If you want to do more challenge with medical data, which are usually private. So this is an interesting feature. It's more hard to take in place, but to put in place. Sorry, but. Yes.
Do you have any historical data about when you submit to a competition, like how much percentage, right, or do they get to publish the work? Like the students love to publish, but sometimes the sponsors do not allow them to publish. They can give the code away, but then can submit to conference or something. Like, what's the percentage or like rough idea?
Sorry, I didn't
get it. So let's say that students submit their participation competition, right? So they want to write a paper. Like you said, there are opportunities, jobs, and papers. Like from the past experience, like is it a high rate that people publish their work? Like
Yeah, it's really common. A lot of different competition has. Leads to papers and
conference papers.
Yeah, conference papers is really common after competitions, because there are competitions in really various domains such as biology, physics, and even machine learning itself, of course. So there are a lot of opportunities to publish their work, and a lot of competitions say, for example, that they give the opportunity to participate in workshops or in conferences for example, the 5 first on the leaderboard. So this is quite common, yes.
They actually challenge, like they'll run a workshop at NIPS or whatever, and or IJCNN or whatever, and they have a challenge series with some publisher, and they routinely publish the work. So if you look at Isabel, she's edited lots and lots of papers, because if you win the challenge, you get to write a paper about it. So if anything, it increases publication, I think.
Yeah.
Does it have enough price, or just like participating and submitting is okay?
I don't think everyone wins, but the top ones do, because there's really no statistical difference between the top ones usually.
Exactly.
So but they don't go way down, right?
I know.
Because you submit.
A CDPR for the competitions, each of the competitions has like a chair for each competition, and those chairs decide who to publish, and it's based on results, but also based on the submission. And in general, these competition papers are much shorter. They're I think CDPR is max 4-page, whereas the competition paper is 4-page, and the conference paper is 10 pages.
Yeah. So just to be clear, because I was a little dim on this for a second, the papers that we're talking about are papers by the participants discussing their solution.
Yeah.
That's what
because a lot of advancements are made by participants, but As an organizer, you usually also can publish analysis of the competition papers and comparing the different methods that got submitted and the result of each. So even as an organizer, it's common to publish papers. And, so everyone's win.
Everybody wins. So could you discuss a bit about the actual, for code submission competitions, kind of the different languages that are used? Is it always just Python? Or
for now, it's a lot Python, but it's not a feature directly of CodaLab. As an organizer, you create your ingestion program, which is the program that is going to load the code and train the model and everything. So if tomorrow you want to organize our competition, for example, just up to you to create that ingestion program. And by the way, I'm going to create an R ingestion program soon. But basically, it's not a limitation of the platform itself, but more like most competition use Python, so that's why usually it's a Python code submission, but it could be anything really up to the organizers to create that.
So a question that we talked about, I think, yesterday, in talking about this, what sort of libraries are available? Like if you want to create Python-based models for your code submission, what sort of libraries are generally available, either on Kaggle or on CodaLab, for actually what do you have access to that you can
generally
include
you have like the big libraries like sklearn and TensorFlow, PyTorch, things like that. But as an organizer, if many participants ask for a library, you can add it easily. Or so generally there are no big issues with that. So, and even if you really need your library in your code submission, you can just add it as a package in your submission. It depends on how much data you're allowed to upload, but you can usually add your package in it, and it will just be run as if it were your code, let's say. So yeah, that's not a big limitation. Other questions or remarks?
What are the common metrics you guys use? So you use prediction accuracy and stuff?
Of course, it really depends on the task because there are really various tasks. So I can say with my experience in organization, but there are thousands of different challenges. So basically, in classification, IUC is widely used, but if you are in regression, you are going to use something else. And you can have also multitask challenges, so you can use as the final metric your ranking in each task, for example. So it really depends on the task. Personally, I use IUC a lot, I guess, but it's really various.
Did you want to talk about how we're going to be using challenges?
Yes, well, so at RPI we use challenges two ways. One is we use the challenges as Adrien said in class for CodaLab, and we use it for class projects so we can make them a little open-ended and kids explore stuff. And also we find it very motivating, right? We also use it to onboard students into our research program, so we'll have them do a challenge as kind of a team exercise to get them used to our environment and working together, and you know, they find it cool and stimulating. So that works out well. And the other thing we did is this year we actually entered a public challenge, which is called run by AHRQ, which is the Health Research Quality
Agency for Health
Research Quality. Yeah, I should get that by now. In the United States, and they offered a competition, and they gave us a 10,000 prize. Of course, we're spending like 7 times that entering it for the second phase. So we went to phase 1. It's called Mortality Minder. We're looking at the social determinants of mortality. And we're going for phase 2 for a prize of $50K. So we'll only lose a little money.
That's
So
right.
it really works for getting people to work hard.
We'll almost pay for the labor.
For people labor. We have like 20
several of which are in this room.
Yes, yes, so that's exciting. So I think it's quite motivating to both the students, I guess professors too, because we're doing it, right? It does seem to work.
It's because it's a kind of game, so
Yeah.
it's really fun to play.
Yeah, and that challenge is a little bit different. It's more of a qualitative challenge. They don't tell you what problem to solve. They just say solve a problem. And we also run challenges that are qualitative on campus. We have what we call datathons, where we'll present a problem. But typically, we don't usually evaluate predictive accuracy, but I think we will in the future.
Yeah.
Now we have Colab, but we'll have people present their solutions and even make up the problem. Like we'll say, use this data to tell us something about that. We kind of do qualitative and quantitative changes routinely. Trying to see. I think I should write some quick because I go to day.
Any other questions? Well, let's thank our guests.
Thank you too for